Hello everyone, this video is for grade 10, day 19, chapter 3 and the topic is linear equation in two variable. I got a request from my very dear student to explain problem based on upstream and downstream. So this is the topic for today's video. So before we solve the question based on upstream and downstream, it's important to understand the basic concepts of upstream, downstream, boat, current, still water, right? So first I'm going to explain that basic concepts and after that we'll solve problem based on that. So suppose this is my lake or pond. So have you ever seen a lake or a pond? How does it waters look like? It's a still water. The water doesn't move. Still water means the speed of water is 0. I'm talking about lake. It's a closed figure and the water inside it, we can store water inside it and there is no movement in the water, right? So if I place a boat in a lake, what will happen? It will not move, right? For example, this is my lake. You can consider this is my lake and I am putting a boat. Now this is still and the boat is also still. So what will happen? It will not move until and unless if I will use some external force to move this boat. Either it can be manually, I can row, or I can use engine. I can switch on the engine, then only in that case the boat will start moving, right? So this is my still water and this is my boat. There is no movement in the still water and this is my boat which is also still, if you can see that. Now I have used external force to move this boat, which means the boat will have some speed and that will be the speed of the boat itself because the speed of the water is 0 over here in case of still water, right? So on applying external force, the boat will get some speed and that will be the speed of the boat only, right? So the same thing I have written over here. If you put a boat in still water, it will not move unless you do something like by starting the engine or manually, right? So suppose this is my lake or pond and this is a boat inside it and b kilometer per hour is the speed of the boat, own speed of the boat. Then I can say that this own speed of the boat is the speed of the boat in still water because the still water doesn't have any speed, right? Now from distance formula we know that distance equals to speed into time. So the formula is going to remain same because speed will be considered as the speed of the boat in still water and time will be the time and this is the distance. So so that was the case of still water. So in this case, the boat can move with any help or opposition of water as water is still, right? Now let's talk about the second case, the river case. Have you ever seen a river? The water keeps flowing, right? It's keep flowing. We cannot store it. That means the water has some speed. Let r kilometer per hour is the speed of the river. It is in mathematics we call it as the speed of the current also or stream also. So in question if you see any of the three terms it means the same thing, speed of river or current or stream. It's the same thing, alright. So here r I have considered as the speed of the river. Now see. So if I simply put a boat in a river, it will start moving without turning on its engine, isn't it? Why? Because the river itself is moving. This is my river and itself is moving. So suppose this is my river, this is not a still river. Suppose this is my river, right? And if I put a boat in the river, now the boat is not moving, but since the river is moving, so boat will also start moving. Can you see that? So by doing this, it means the river has a current, it is moving. Now I'll simply put a boat in a river, right, in a river which has a speed. So boat is also moving with the speed of a river. Right now I have not switched on the engine of the boat, but still the boat is moving. Why? Because the river has a current, has its own speed. But in case of pond, the water was still, so the boat and the water both were not moving when we have not switched on the engine. But here, even if I'll not switch on the engine, the boat will move. Why? Because the river has a speed, current. So what if the boat, suppose if the boat also has a speed b km/h, right? Now r is the speed of the river which is moving, and the boat is also moving, because here this is the speed of the boat and this is the speed of the river. So both are moving, the river is also moving, the boat is also moving. Now in this case, the boat has also a speed and the river has also a speed, right? That means this is the speed of the river and this is the speed of the boat. This is not still, this is actually moving. So both are moving, right? So now it gives two cases. Case number 1, if the boat moves in, if the direction of the boat in which it moves and the direction of the river are same, this is called downstream. Downstream, when the direction of the boat and the direction of the current or river are same, then in that case it is known as downstream. As it is moving in the same direction, then that means the river speed will support the speed of the boat, right? So the net speed is going to add on, that is the speed of the boat plus speed of the river. We are going to add it, right? Why downstream? Always remember, downstream means we are going to add both the speed because it's going to support. Downstream means that the boat and the river is moving in the same direction. Case number 2, if the river is moving in this direction and the boat is moving in this direction, like this, right? So what will happen? Definitely the current going to oppose the boat movement, isn't it? The boat is moving in this direction and the river is moving in this direction. So in that case, we call it as upstream. Why? Because the boat and the river are moving in opposite direction. So definitely the river will oppose the motion of the boat. Oppose the motion of the boat. Then definitely in that case, the speed of the boat going to decrease. So it is the net speed for upstream is b minus r. Always remember, from the speed of the boat we subtract the speed of the river or stream, right? Don't do r minus b. Why? Because we are going to find the speed of the boat. So if the speed of the boat is moving in this direction and I'm opposing this motion, then definitely the speed going to reduce. And by what amount it will reduce? Because it depends on the what kind of force we are applying over here. So that is the speed of the river and this is the speed of the boat. So this is called upstream. Upstream means in opposite direction when the movement of boat and river are. And in that case, this is my equation. So now this equation and this equation is going to be constant in every case. These are the basics of upstream and downstream. So depending on the speed, the distance formula will change. Distance equals to speed into time, we know. So net speed we need to find in that case. So in case of net speed, definitely the downstream means water helps the boat and upstream means water opposes the boat. So at place of net speed, we are going to use this speed in case of upstream, and in case of downstream we are going to use this speed. So I hope the basic concepts are clear. So now we are going to solve two questions based on that. The question number 1, a man can row downstream 20 km in 2 hours and upstream 4 km in 2 hours. Find his speed of rowing in still water and also find the speed of the current. Now as per the question, whenever you get question like that, let us assume that the speed of the man in still water is x. always consider it as x, because that will help you to avoid the confusion, right? So in still water means there is no movement in the water, right? So let it be x, and this is the speed of the man or speed of the boat, because as I said that if I'll put any boat in the still water, the speed is going to be same. So the speed of the man is equal to the speed of the boat in the still water, right? That is x kilometer per hour, and the speed of the current is y kilometer, right? Now definitely downstream means we'll add both the speed, and upstream means we'll subtract. Now what, x minus y or y minus x? Definitely from boat speed we subtract the river speed, right? Now the river speed is, current speed is how much? Y kilometer. So that's why x minus y kilometer per hour, right? Now it is, we know that speed, downstream speed equals to distance by time. It is given that a man can row downstream 20 kilometer in 2 hours. This is the distance, this is the time. So distance by time, which is 10 kilometer per hour, which will give you speed, and speed is how much? X plus y. So I can say that x plus y equals to 10. Similarly, he can row upstream 4 kilometer in 2 hours, which means the distance is given 4 and the time is 2 for upstream. This will give you the upstream speed, and which is equals to 2 kilometer, and we know that upstream speed is given by x minus 1. So now you have two linear equations in two variables, simplified by elimination method or any method you want to. From there you will get the value of x and y. So the speed of the man in still water is 6 km per hour, and the speed of the current is 4 km per hour. So likewise you can get the answer. Let's solve another type of question, that is a boat goes 16 km upstream and 24 km downstream in 6 hours. Also it covers 12 km upstream and 36 km downstream in the same time. Find the speed of the boat in still water and that of the stream. So here I have to find the speed of the boat in still water and that of the speed of the stream as well, right? So let, again, like usually we do, speed of the boat in still water is going to be x km per hour and the speed of the stream is y km per hour, right? So upstream is going to be x minus y and downstream is going to be x plus y. Remember, I took x as still water and y as current, stream or running water, right? That's why upstream is x minus y and downstream is x plus y. Speed equals to distance by time. So time equals to distance by speed. Why I am using time equation over here? Because it's given that a boat goes 16 km upstream and 24 km downstream in 6 hours. Therefore time is given. So time equals to distance by speed. So upstream, how much distance does it cover? 16 km. So distance, and as it is going upstream, what is the speed of upstream? X minus y. So 16 divided by x minus y plus. It goes, along with that there is a sign and, which means plus. It also goes 24 km downstream. So distance is 24, speed is x plus y. And together it takes how much time? 6 hours. So this is my first equation. Again, it covers 12 km upstream. That means distance is 12, upstream is x minus y, and 36 km downstream. So 36 by x plus y equals to, it takes the same time. Same time means 6 hours. So these are the two equations. Now we know that how to solve this kind of equation when we have variable at the denominator. We consider it as with some other variable. If you do not remember, then you can refer my previous video in which I have explained about how to solve these kind of equation. You can refer my previous videos. So let 1 by x minus y as u and 1 by x plus y as v. So this is my u, v. So I can rewrite this equation. Again, I can take 2 common from here. It will be like that. And from here, I took 3 common here. So when you solve that, I'm not going to tell you how to solve the equation because that already I have explained you. So my main motto was how to frame equation of upstream and downstream, which I have explained. So when you solve this question, you will get, after solving, u equals to this much, and at the value of u is, we know, 1 by x minus y, so you will get equation in the form of x minus y. Similarly, you will get the equation of v. When you solve that, you will get the value of x and y as this. So I hope the concept of upstream and downstream are clear to you. based on today's class. Here I am giving you two assignment question to practice. This question, as you can see, that already asked by CBSE in 2015. So try this out and see whether you are able to solve. I have provided the answers as well. Please write your views, like the video and subscribe the channel and share it. And in case of any doubt, please write it in the comment box, and you know that you can download the notes from the description part of the video. Thank you everyone and take care.